Warm welcome, everybody. Thank you for being here. Go ahead and get yourself ready with a notebook. Grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. Today we have a multiple choice AP Calc problem. And this is something that you can expect to be on par with the difficulty of like the non-calculator section for the multiple choice portion of the exam. As usual, give yourself a few minutes. In this case, give yourself 3 minutes. That's roughly the average time per problem. If you can do it in 2.5, that's great. Some problems take longer than others, of course. Once you give yourself a shot to try to do this problem, then you can come back, unpause the video, see how it's done here. All right, let's get started. So we're given a piecewise function, and we know that piecewise functions are potentially broken, right? So we have this quadratic function, maybe it's going something like this, and then we have this cubic function, which we're hoping is connected, and we're also hoping it's smooth because we're told that it's differentiable. And we're asked for the value of b. Now, if it's differentiable, that means that it's connected, but also the derivatives on both sides are connected. It may seem weird to call the derivatives connected. Both sides. So what do I mean by connected on both sides? What I mean is that the left and the right side have the same derivative. So we're going to have to use both of those facts in order to solve for b. So if they're connected on both sides, that means we know that the left side at -1, so I'm going to plug in -1, we know that the left side at -1 is equal to the right side at -1. So you can plug -1 into the piece that represents the right piece, and you can set those equal. So we're going to get 2a minus b plus 6 is equal to -3a minus 2b minus 4. And if you move everything over to the left side that has a variable, we get 5a plus b. And if you move the stuff with no variable, the numbers to the other side, we get, what is that, -10. So we're kind of stuck there, but we're going to use that equation. Now let's find out what we would get when the derivatives are connected. And for that, we're going to have to represent, of course, the derivative. So the left side derivative is going to be, going to cheat a little bit, 4ax plus b. And then for the left side derivative, we're going to have 9a times x squared. And I'm going to cheat a little bit. What does it say? Minus 4bx plus 4. And we're going to say the same thing. We're going to say that it needs to be connected on both sides. So the derivative on both sides needs to be equal. So we're going to have -4a plus 6. That's a 6, not a b. I know my 6's look like b's, kind of notorious. And then on the other side here, we're going to have, plugging in -1, we're going to have 9a plus 4b plus 4. Let's move everything over once again. Let's move stuff over here that have variables. That's pretty easy to do. So we have 13a plus 4b equals 2. Does that seem right? Yeah, if we subtract 4 on the other side, we just get 2. Oh, was it a b? It was a b. See, my b's look like 6's. It's notorious. That is a b. There we go. So this is going to become 13a plus 3b. And then we're going to have -4 on this side. Okay, so again, we get kind of stuck here, but if we put these together, we can reconcile. We can have 13a plus 3b equals -4, and then I can take this equation and multiply it by -3 to perform an elimination. Adding those together, I recognize that that gives us the value of a first, not the value of b. So if you wanted to go for the value of b first, you could eliminate a. It's just a little trickier. And then at this point, I would just plug in that value for a. You can plug it into whichever one, doesn't matter. This will become 169 plus 3b. And so if we add 169 to the other side, we're going to end up with 165. And then we get b equals 55. Okay, so that is what they were looking for. I guess the answer choice is D. So a quick one. Using the fact that differentiability means that both pieces are connected, but also their derivatives are equal on both sides. So you have to use both of those to get an equation with A and B, and then solve that system of equations that both have A and B. All right. That's enough blab out of me. I'll see you guys next time in the void.